another distinguished person from the University of Illinois. So, I welcome Dr. Krishna R. Reddy. He is the Director of Sustainable Engineering Research Laboratory from the University of Illinois. So, before Sir joins us, I will also introduce Sir to you. Dr. Krishna R. Reddy is a professor and a distinguished researcher in the University of Illinois and the Director of Geotechnical and Geo-Environmental Engineering Laboratory. He is also the Director of Sustainable Engineering Research Laboratory in the University of Illinois. His research areas include Geo-Environmental Engineering, Environmental Remediation, Solid and Hazardous Waste Management, and Landfill Engineering. And he also works on Sustainable and Resilient Engineering. Sir, it is our honor to have you from the University of Illinois, and we would like to have a little bit of your knowledge, sir, if you could share for us from all your international experiences. Please, sir, over to you.
All right, good morning, everyone. Thanks for being here. I'm very happy to be here. I'm from University of Illinois at Chicago in USA. But I'm visiting IIT Madras as an adjunct professor and also Fulbright scholar. So I'm going to be at IIT Madras until end of July. And this gave me great opportunity to be in person here and meet a lot of people in person. I was supposed to give presentation online when it was scheduled online, but then I'm glad that things worked out fine and I'm able to be here, in person. So the presentation title in the program is Sustainable Engineering for Climate Change Adaptation, but I would say, this subtitle that you see there, Integrating Sustainability in Climate Change Adaptation and Mitigation Engineering, that would convey the content of my presentation quite well. So before I get started, I really want to thank Madam Smita and Kalamegan sir for inviting, and Professor Mohan is my host at IIT Madras, and he has been instrumental in inviting me here. And I want to thank all the workshop organizers for doing a fantastic job. I looked at the program, I really wanted to attend, and I've been learning a lot from yesterday, so it's really great. So I'm from Chicago. I don't know how many of you have visited Chicago or USA before, but if you haven't, Chicago is a beautiful place. And now that you know me, so send me an email when you're coming that side, and I'll be happy to be your tour guide. So the last two slides that you see, they are my university. It's right close to the university, downtown. So I am in charge of these two labs, Sustainable Engineering Research Lab and Geotechnical and Geo-Environmental Engineering Lab. My research is on environmental remediation of soils, sediments, groundwater, and stormwater. And I also work on waste management and landfill engineering. And then I also work on life cycle assessment and sustainable and resilient engineering. So today's topic is based on this theme. But my background is civil engineering, and my specialty is geotechnical engineering. So if you want to know more about my research, you can go to that website and get all the information about my research. So I want everyone to take a step back and just think about it. What are the grand challenges that we have, going forward? Okay, I know we're talking about climate change, but let's just step back and see, what are the greatest challenges that we have in front of us into the future. So of course, this theme of workshop is a climate change, and that is going to be a grand challenge going into the future because of all the consequences that we're seeing there. And it's going to impact current generations. We are all feeling it, and it's going to impact the future generations also. But there's another great challenge is this exploding population growth and consequent impacts. As you see, all this depletion of natural resources, increased waste generation, increased pollution, damage to ecosystem, loss of biodiversity, urban sprawl, economic disparity, social justice. These are all things happening because of increased population. And the population is going to increase tremendously going into the future. This is not a model. This is the actual numbers if you see it. And population has been growing a lot. And as a consequence, we're going to see all these things. And these are going to become more and more as we go into the future. So this is the grand challenge. But if you look at one interesting graphic here, I plotted CO2 emissions, greenhouse gases, and then if you plot if you plot it on the other side population, there is a good correlation. So what does that mean? Greenhouse gases are due to increased population. So if you have to tell one thing that we have to worry as we go into the future, that is the population growth, explosive population growth. So what can we do? We cannot reduce the population. That's a very sensitive topic. Now the challenge is how can we do things differently in spite of population increasing? That's the greatest challenge that we have ahead of us. So if this population is increasing, all these issues are coming up, then how can we achieve sustainable development, right? So the sustainable development definition that everybody uses this, World Commission on Environment and Development or Burnland Commission report. So they use this one, development that meets the needs of the present without compromising the ability of future generations to meet their own needs. So with the problems that we have, current generation is being affected, and future generation is going to be affected much more than what we are going to be, So you may not be worried about, us, but your kids and maybe grandkids are going to be suffering a lot as we go into the future. So how can we have this sustainable development if we have increased population growth and climate change, all these things that are happening? So the UN suggested what we need to do to be sustainable or to have sustainable development. So everybody knows about this, Sustainable Development Goals. So we need to focus on these things in order to be sustainable. So of course, this workshop is focused on climate change. Climate change is one of the Sustainable Development Goals. But what I like to emphasize is that all these SDGs are interlinked. The climate change can affect all the SDGs that you see here. So it's very important to think these as interlinked rather than individual sustainable development goals. So the question is, how are we going to achieve these ambitious goals, right? So that's the question, and a lot of people are working on these things, and this is the question that we need to address. So one of the problems, as I said, is climate change, and that is the focus of this conference. And you are now familiar with this terminology, climate mitigation, climate adaptation. So the climate mitigation is the one that we really need, right? So, what is the root cause of the problem? Greenhouse gases. Why don't we eliminate greenhouse gases? And then this problem will go away, right? So that's not going to be happening. So we are, having a continuous increase of these greenhouse gases, and decreasing them is going to take a long time. Even if we put in all of our efforts, it's going to take a long time. So that's why we need to think about adaptation, because some of the consequences that we are facing now, they're not acceptable, right? So that's why we need to think about adaptation, basically coping up with the adversities that we are facing. So you can take a lot of different actions, as I shown in this Venn diagram, but some of them could serve both mitigation as well as adaptation. So mitigation is all about reducing the greenhouse gases. Adaptation is not worrying anything about greenhouse gases, but basically trying to cope up with the consequences of increased greenhouse gases. So the problem is, these climate impacts are intensifying. That's the biggest concern. It's not like, okay, we are on a slow motion and we can take some time and address these issues, but that's not the case. So these impacts are, intensifying, and it is having a lot of consequences. This is coastal erosion. If you have these kind of damages, how can you survive, right? And this is again in the U.S., in Texas, the whole subdivision is filled with flooded water. So if these things are happening, how can you say I'm not going to do anything and sit tight and let climate change go away, right? So we need to act. That's why the climate adaptation is important. And the climate adaptation is also known as resilience. And the definition of the resilience is this. So whatever you are dealing with, it should have an ability to cope, adapt, and grow in the face of foreseeable climate and extreme weather impacts. It could be flooding, it could be extreme heat, it could be sea level rise, over a life cycle of the project. So think about not today, tomorrow, but if roadway is going to be built for 50 years, you're talking about in 50 years, what would be the impacts of it. So what this graph shows is, okay, you have designed, as usual, then something extreme event happens, you're going to compromise the performance. So it's going to, performance is going to go down, and then, hopefully it doesn't go down to the level that you have a disaster, catastrophic failure. So hopefully you will maintain some certain performance, and then after the event retreats, so your system should return back to some acceptable levels, or in an ideal situation, it should get back to the same as original, or in a very idealistic sense, it should perform even better than what it is initially designed for. So this is the challenge that we have. So this is the climate adaptation or designing for resiliency means, we need to be thinking about these things as we go into the future. So how do we do this one? I mean, there are a lot of different ways to do it. I call this one adaptive management methodology or climate resilient design framework. So what do? So you identify the climate change hazards of concern, what is in your area, right? These climate impacts are very different to different places. If I'm not in a coastal area, I don't have to worry about sea level rise, if I'm inland. So what are the, climate change hazards that you have at your location? And then you identify which ones you really are going to be worried about among the hazards that you're going to be of concern. And then, whatever you are designing it, evaluate the performance of that. And then, if you are compromising the performance, what are the risks associated with that one? And this is called vulnerability assessment. So you really need to think about, you need to do this one for anything, that you are concerned about it. So if you have a high risk, then you need to do something, right? So you need to look at these resilience measures. How can you change your design? If it's a new thing, you can incorporate in a new design. But if it is an existing system, what can you do to make sure that it does not undergo damage if this perceived climate change hazard really happens? So you look at different options. You will have multiple options. Out of multiple options, you look at, you prioritize which ones are effective, then you select that measure to be implemented. So this is called resiliency measures selection. Then after that, you implement it. All right? So basically, when you implement it, if the flooding comes or sea level rise happens, so you are okay. But you need to monitor periodically and assess adaptive capacity. This is extremely important because engineering designs, in engineering design, for example, if I'm designing a building or beam or column, I know the loads, and loads are not going to change that much. But in this case, the driving factor is the climate hazard. The climate hazard is not well defined. So that's, and it's very hard to, know exactly that hazard. So there's a lot of uncertainty. So that's why we need to keep monitoring to see what the actual hazards are, and if it needs to be changed. So it's kind of a iterative process that you have to follow. But in all these things, one thing I want to mention is that you need to keep stakeholders engaged, public, planners, designers, owners, because every stage you are taking some risk. So there's nothing like risk-free. If you are a designer, you cannot guarantee that you're going to perform. You're going to guarantee the performance of it if flooding happens or something happens. So there is a risk that you want to. If you want to have no risk, it's going to be cost prohibitive, in terms of the design. So nobody wants to do that one. So stakeholders engagement, especially public, letting them know, what risks still, exist. That's important. And as I said, this is a kind of iterative process that we have to look at it. And in the US, we have a lot of data sources and tools to look at this climate hazards. We use the NOAA and National Weather Service, and we do some modeling, and we can develop some site-specific maps and matrices for design decisions. So one of the biggest thing is, what hazards that we need to design it for. So I want to give you a simple example of, the resilient design. So let's say this is the building. This building is being proposed at a place called New Orleans in US, right? So what do you see in this building? Generally, foundation is at the ground level. Foundation is not at the ground level, it is elevated. Why? Because at this location, flooding is expected. And they modeled it, and based on that modeled depth of the flooding, and they raised these foundations, the building. So this is what we are thinking about when you talk about resilient design, thinking about what kind of hazard that we're going to have into the future, and then incorporating that one now before we wait until that thing happens and undergo the damage. So this example, clearly, a lot of things are happening like this in the US in actual designs. And this is actually built. This is a library building in New Orleans. And also, you just don't want to say, oh, I have a foundation, raised, and I'm not going to have any problems. But you need to be proactive. You see on the back of this library is a green infrastructure that allows the infiltration of the rainwater, not allow this flood water level to increase. So you need to be proactive in multiple fronts. So I want to give you this another example to understand what do you mean by resilient design. Okay, this is the railroad line that goes from Los Angeles to San Diego in California. Right? It's along the coastal area. All right? And look at it. So what is predicted based on the sea level rise is that if the sea level rise as predicted, this whole railroad track is going to be underwater. The whole thing is going to be underwater. So this railroad is going to be out of business. Right? So what we are doing, what is planned is this. So basically you have the foundation, right? The pier wall. And the pier wall is going to be jacked, you're going to use the jacking system at the track, and then you increase the height of the pier, right? Okay, so that's the plan. This is the kind of a resilient design. So what you have to do is thinking about if you are looking at the new systems, you want to design it such a way that it can be modified to accommodate the future impacts. So this is another, we have a lot of landfills right next to the water bodies, and then we are expecting the erosion, surge, and all those things. So now we are going back to these sites, and then we are retrofitting these so that landfill covers remain the same, because underneath the cover is the waste, and these are right next to the surface waters, and the water level rises, surge happens. And then, the cover, the soil on the top is going to be eroded, and then you have waste that's coming into the water. So we're going actively to retrofit these things. So those are the things that we are doing. So those are called adaptive measures or resilient designs. But that's a temporary solution, right? That's a temporary. You're not, addressing the root cause of the problem. So the adoption and resiliency options are going to be limited or going to be very challenging if we have continued greenhouse gas emissions. That's the root cause of the problem. So that's why, we need to be, also focusing on reducing the greenhouse gases, which is the root cause of these climate impacts. That's known as climate mitigation. So a lot of work is going on at a lot of different levels. So IPCC came up with this, Working Group 3 report, mitigation of climate change. And then a lot of cities in the US, they have their own climate action plans or climate mitigation plans. So if you think about these things, IPCC report, if you look at it, what can be done to reduce the greenhouse gases, they identified these different mitigation options in different sectors. Energy is one big thing. So they estimated how much greenhouse gases could be reduced in these different sectors. So energy sector is one big thing. Agriculture sector is one thing. So I'm not going to go into all these details. You can get IPCC report and look at it. If you want to make a big impact on reducing the greenhouse gases, what are the things that you should be doing? So these are the things. And then you have, buildings are going to be huge greenhouse gas emitters. And, you have other transport industry is one thing. So you can look at all these different fields, and you have, these different options that you can follow to reduce the greenhouse gases. So just, Chicago, the city that I come from, they just released, last week, their climate action plan. They had one, they updated this plan. So you see a lot of people say, carbon neutral, but, Chicago, being very honest here, they're going to have 62% reduction in 2040. a lot of people say zero, but zero never happens. Here is the things that there's a practical way to reduce the greenhouse gases. So the goal is by 2040. It takes time. It's not easy to get reductions because you are emitting constantly, and then on the top of it, you have to reduce what you're emitting, and then on the top you have to reduce. So that's a lot of challenge. So there's a fine print. You can get it from online. This report, but some of the actions that are proposed are listed here. There are many other things. But one thing I want to mention is, the climate action plan is to reduce the greenhouse gases. But in the process, we should be looking at co-benefits. So how is it going to benefit the people? How it's going to benefit the economy? So these are all the things that you need to consider when you are planning these things. So the resiliency, I mentioned about it. Climate mitigation comes as a part of the sustainability. So basically, in the long run, we want to have a good economy, good environment, good society. So sustainability is a kind of a mitigation plus more to look into having a really sustainable development into the future. The resiliency is taking care of these impacts that we're going to see. They overcome the unexpected crisis, adapting to turbulent change, and flourishing in a chaotic world. So that you need to make a distinction between these two things. So people use synonymly, but to me these two are different. So we need to think about resiliency, but sustainability, climate mitigation, as well as additional things that you need to look at it. So as I mentioned, again, going back to this slide, so when we do the climate mitigation or climate adaptation, we should be looking at achieving this, at least some reaping the benefits of these other sustainable development goals. So that's the important things to look at it. So then how do we achieve this one? The question is, okay, that sounds good, but how can I do these things? How can I integrate the sustainability? There are many definitions for sustainability. The functional definition of sustainability is this. You need to consider this triple bottom line: environmental, economic, and social aspects through the life cycle of the project. So this is the important definition of sustainability. So you must have seen this, that diagram that looks at the environmental, social, and economic. In addition to whatever you are designing, it should perform its function in a safe manner. But these are the broader impacts. So these environmental aspects, if you look at in triple bottom line, that includes the greenhouse gases. So basically, you are doing the climate mitigation, but in addition to that, you are looking at air pollution, all kinds of environmental impacts, the social benefits and economic benefits. And then one thing that we need to look at is you look at the life cycle. A lot of engineers, we don't look at it life cycle. We'll talk about the project construction, and operation and monitoring. But we need to look at from the raw material acquisition to the material manufacturing to the construction, maintenance, and all those things. So I use this book as a textbook to teach a course on sustainable engineering, to teach them about what do you mean by sustainability and how do you do the sustainability assessments. So the sustainability projects get confusing, but you need to realize that the sustainability can be at different scales: global scale, national scale, regional scale, business or institutional scale, or sustainable technology scale. Maybe a lot of work that is being presented here could be the regional scale. You can contribute at any level. So in my case, in teaching students in my university, I focus on the last one, sustainable technology scales. And irrespective of which scale that you are looking at it, we need to have some assessment tools. Whatever you are doing, you can say that is sustainable, but how can you measure the sustainability? So there are one tool that I would highly recommend you to consider is called Envision rating tool. So this rating tool has these different dimensions: quality of life, leadership, resource allocation, natural world, climate and resiliency. Climate and resiliency is your, the climate change issues. But in the process, when you're designing, you need to address these other sustainability aspects. Some of them are social, some of them are economical. And it's a great way to look at it. And these kind of things are happening in the US. So this is Sun Valley is a location in California. They have all these flooding problems, they have it. And they wanted to come up with the sustainable solution for this one. They came up with this drainage and underground infiltration system, and they applied this tool, and they were able to change the design to maximize the sustainability benefits. And based on the rating tools, you can score what is the level of sustainability that is incorporated, and there are rewards for depending upon how much score you get it. So. On the other hand, that kind of project is, that kind of a rating tool is good for applying at a regional scale, but I was looking at more project component level. So I developed this tool. It's called Equalizer, basically tiered quantitative assessment of life cycles, sustainability and resiliency. It integrates the technical aspects, resiliency aspects, and sustainability aspects. So, this is what I'm trying to promote, in teaching and also in industry to day-to-day engineers. So this basically has the 4 phases, and each phase, has a step-by-step process that you can follow. A lot of times what happens is, people want to do something. They want to do the resilient design, sustainable design, but they don't know how to start. So this is kind of a roadmap, step 1, step 2, step 3, step 4, you do it. Doesn't matter what you are doing. Let's say you are designing a beam or column. It's, simple, roadway, anything, this kind of protocol works. So the first one is all about addressing the resiliency. First thing that you need to look at is, make sure that your, design is, resilient to the climate impacts. As I mentioned, we follow this adaptive methodology, and then one thing that you need to do is quantify the resiliency. So, okay, we will have multiple options, and for each of the options, you can come up with these indicators and metrics, and then you can calculate the resiliency index. And if I have 2, 3 different options, I can look at the resiliency index for each option. The one which has the highest resiliency index, so that would be the best thing. And then you choose the possible resilient options, and then conduct the sustainability assessment. The sustainability assessment is all about looking at the environmental indicators, social indicators, and economic indicators, and also adding the resiliency indicators, and having the metrics for them. So you need to be able to calculate those metrics. And this is where it is challenging. And this methodology will allow you to use any information that you have. So it could be qualitative or quantitative. It's very flexible. Sometimes you just have a best management practices. So you can still incorporate those things. Semi-quantitative, more like a rating tools, or you have a life cycle assessment, more detailed quantitative tools. So this methodology can allow you to input whatever the information that you have, and then you can do this assessment. So the tiered approach is the one that I've been recommending, because a lot of times when you do these assessments, the data limitations is the biggest problem. And so in the phase 3, finally, once you have that one, you can calculate the sustainable resilience index. So how sustainable it is, how resilient it is. So that is the final output you get it. And then, once you get that one, in the framework, you see that there is a stakeholders engagement at every level. You cannot do anything without stakeholders engagement. So each phase has this stakeholders engagement. Sometimes these numbers, don't matter at the end. Decisions are made by the stakeholders, whatever they prefer. So the budget is one thing, and the social acceptance, what people accept, and stakeholders' preference is the one. So just to show you how this could be applied, we have a geothermal system. The buildings are powered with that, and other option would have been using the conventional heating and cooling system. So, is it sustainable? Using of geothermal is resilient and sustainable? So I applied this framework, and then I looked at the resiliency aspects, and then I calculated what it would be the resiliency index of it. There is not much. This geothermal is slightly higher than conventional from the point of view of resiliency, coping up with the extreme heat, for example, in Chicago. But when you apply the sustainability factors after resiliency, you see the huge difference in geothermal. So geothermal has the highest sustainable resiliency index. So these kind of assessments will document, demonstrate quantitatively how good you are doing from resiliency and sustainability point of view. But as I told you that the final decisions on all of these projects is not based on the numbers. So the numbers guide you, towards the rational decisions, but a lot of final decisions are made based on these other factors. So I just wanted to mention that one. So, and one of the things that we are doing now is that we need to look at resilient and sustainable designs. So which ones have a possibility, right? For example, coastal areas, we used to put these seawalls, concrete seawalls. They are not resilient, they are not sustainable. So we are looking at these floodable parks as an option where, if a surge comes or sea level rises, the park is going to be inundated. But that's okay, nothing is going to be damaged. So we're going into these nature-based solutions extensively. Even in New York, we are using these floodable parks. I mean, this has become very important from the lessons that learned in New York, Hurricane Sandy. And now they mapped what areas are going to be affected by future hurricanes, and they're looking at these kind of systems. I just wanted to mention this because, instead of having a seawall, they are constructing these parks in a clever way. So as you see here on the top, it's a park with the stairs, and people can come and sit down and enjoy the ocean and everything. But then when hurricane comes, right? People are going to run away, go home. And then you see that steps that you have, that becomes a retaining wall system. So as the water level rises, you can see that the other side is the city is not going to be flooded. So it's kind of these kind of designs, resilient and sustainable, and social and economic aspects, all those things. So again, this is kind of a park. And again, this is one side is the ocean, and the other side is the city. And look at underneath this, the train track is ugly. So they want to convert this one into this kind of area where it could be utilized. And again, you see on the left side, the stairs that are become like containment if the water level rises. So when water comes, you can see that the stairs are protecting the other side of the city, and you can even have this. Systems that hinged, and then they can lift it up to increase the height if you want it. So there's a lot of work is happening all over the world to make sustainable and resilient designs, all based on the nature-based solutions. So these are some examples. And this is again, one of the smart systems. This is in the middle of the city. They designed this playground, but it will provide a storage for if you have a flooding. So the area is not going to be flooded. It's a smart area, right? Smart, like they put it a little bit under. You see the ground elevation, they went it down a little bit. So that becomes a temporary storage pond. When there's no water, it's a nice playground. But when there's a lot of water, that becomes the storage pond. So this is my last slide, take-home message. I generally don't put conclusions and summary and all those things. I put these take-home messages. So the first thing is, I want you to take, there's a lot of emphasis here on climate adaptation. So we need to, choose climate adaptation options based on this adaptive management methodology I mentioned. The reason why we need to do this one is that there are terms, these people use this one, non-stationary, uncertainty, unknown unknowns, because the predictions, there's a lot of uncertainty. So you need to take a step. There are a lot of studies that look at it. The longer you predict, there's more uncertainty. So if you predict for a shorter duration, you have a less uncertainty. So you go in that step. So that's the first step in terms of the climate adaptation. But climate adaptation is only temporary measure, right? I mean, temporary in the sense even that runs for many years, but I call it. But long run, the solution should be the climate mitigation. So we need to be focused on controlling the greenhouse gases. And these options are very impactful, and we should look at not just focusing on the reducing the greenhouse gases, but also reap the co-benefits. That's on climate mitigation. And then I want you to consider the sustainability in all the things that you are doing. Either it could be adaptation or mitigation, but in addition to the focus, look at all the social, environmental, and economic benefits that you have to promote the sustainable development. I like using the sustainability assessment tools. I like to quantify the sustainability, because we can argue each other that what you are designing is sustainable and resilient. I can say mine is sustainable and resilient, but quantifying the resiliency and sustainability for every project is extremely important. And then the last point is, we are not used to do this, but we need to work with the multidisciplinary teams and promote the nature-based engineering solutions. That's the only way that we can create solutions to address these problems. So thank you very much. This is my contact information, and I don't know if we have time, but I will be around here, and I'll be happy to answer questions, and I can be available to answer the questions through email also. Thank you very much.
Thank you, sir, for giving a very good account of sustainability and resilience, and also for bringing some specific examples from other parts of the world. Thank you, sir. And one good thing is that, sir, you insisted on the practicality of climate action, because theoretical climate action is different, and also commitments and promises are different. But how practical are they is what you insisted, sir. Thank you so much, sir. It was very nice.